Hello everyone. Today we will continue to look at the content of HCI-Storage. Previously we talked about several different types of front-end interfaces. Next we will introduce several types of back-end interfaces. Mainly we will introduce about 100 GB RDMA interface and 12 GB SS cascading module. These two types. First, let's look at the first type. From the appearance, everyone can see 100 GB, right? Its speed is very fast. So its interface, like the several types we mentioned before, just like the front-end interfaces, right? Its speed is relatively fast, so the number of interfaces here is relatively fewer, only 2 interfaces. These 2 interfaces, in fact, both of them are optical ports. Both of these are optical ports, and the speed can reach 100 Gbps. This speed is actually very fast. Among the front-end interfaces we introduced earlier, the fastest also reaches 100 Gbps, and this back-end interface is an optical port with 100 Gbps. So, what role does a 100 frames per second RDMA interface module play in an actual storage system? Actually, it plays a slightly different role compared to some of the front-end interfaces we mentioned earlier. So please pay attention. Firstly, under normal circumstances, it is generally used for connecting the control enclosure to our switch, or for the connection between the control enclosure and the intelligent hard disk enclosure. Well, here you can imagine the storage system as a large city, and the control enclosure is like our command center. It is responsible for managing and scheduling the operation of our entire storage system. In this context, our switch is akin to a transportation hub in the city, allowing data to flow quickly between different areas. Meanwhile, our intelligent hard disk enclosure is like a warehouse in the city. Inside it stores a large amount of data. And our 100 GB RDMA interface module uses a high-speed optical port. It establishes a fast channel between the command center, transportation hub, and warehouse, allowing data to be efficiently transmitted among them. This is a main feature of our backend interface connection. The object? Actually, there might be some differences from the front end. Everyone should pay attention here. It's not that all front end interfaces are the same, and if everything were the same, then why differentiate between front and back? Right? You can think about it this way. For example, in a large internet company, we might have a massive storage system where vast amounts of user data need to be stored and processed daily. This includes user registration information, browsing records, transaction data, and so on. When a user performs an operation, such as uploading a photo or making a transaction, for instance, the relevant data from the user's device will be transmitted to a control module within our storage system. This control module needs to quickly store the data into our smart hard drive module, or retrieve some already stored data from the smart hard drive module for processing. In this process, our RDMA module plays a crucial role. It performs high-speed transmission at a rate of 100 GB per second, ensuring that data can be quickly transferred between the control module and the smart hard drive module, preventing any data congestion. This ensures the efficient operation of the entire storage system, which is the main function of our 100 GB interface module. Next, let's take a look at the second type. As you can see, the speed has decreased somewhat. What you need to notice is that when the speed decreases, the interface tends to heat up more. Generally, with 4 interfaces, the speed won't be particularly fast, but with 2 interfaces, the speed will be somewhat faster. Here, we have 4 interfaces. The speed is 12 GB. This is what we call a cascade module. We refer to it as a cascade module, and its name is somewhat different from the previous one. From the appearance, right? It has 4 ports. These ports are actually the key parts for connecting with the outside world to facilitate data transmission. If you add up the 4, how much would it be? Adding up the 4, it's actually 48 GB. Although a single one isn't particularly fast, when you add up the 4, the speed is actually quite decent. Our 12 GB SS cascade module here is mainly used to connect the control enclosure and the 2U SAS hard drive enclosure. Let's continue using the analogy of a storage system as a city. We'll use the same analogy example as before. The 2U SAS hard drive enclosure. It's like a large-scale warehouse in our city, specifically used to store large amounts of data. And our 12GB SAS Cascade module is like a fleet of transport vehicles connecting the command center and these large warehouses. It builds a data transmission bridge between the control enclosure and the 2U SAS hard drive enclosure through our 4 Cascade module Cascade ports. Well, for example, in a company's data center, there is a large amount of business data that needs to be stored and managed for the long term. This data is generally stored in some relatively large storage hard drive enclosures, such as our 2U SAS hard drive enclosure. When the company's business system needs to read or write this data, our control enclosure will communicate with the 2 SAS hard drive enclosure through our 12GB SAS cascading module. In this way, whether it's company employees querying customer information or the finance department conducting data statistics, our 12GB SAS module can ensure that the data remains within the control enclosure. And ensure stable and efficient transmission between our 2U SAS hard drive enclosure. These two modules have different main functions and connection targets, so their application scenarios are actually different. However, they are both indispensable important components in the entire storage system, like major arteries, Their focus is not quite the same. Here, you shouldn't compare their speed, as different types don't really have comparable speeds. When we compare speed, we mainly do so with the same type of interface. For example, if they are both optical ports or both electrical ports. Or if they are both using Ethernet transmission, then comparing their speed is not an issue. However, the two types we have here actually have different functions. Even their names are different. Additionally, the first type is called an RDMA interface module, while the second type is called a SAS series module. They are two different types of modules, and their work content is also quite different. For instance, the 100GB RDMA module is more focused on high-speed data transmission. As you can see from the 100GB, it emphasizes high-speed data transmission, mainly providing support for scenarios that require extremely high speeds. The 12GB node module, on the other hand, focuses on a stable connection and data transmission between the controller and specific hard drive enclosures. It ensures the storage and processing needs of daily business data for enterprises. Their application scenarios are actually quite different, and the types included are also different. So, in this case, there's really no need to compare sizes. When it comes to comparing sizes, you should refer to the interfaces we discussed earlier. Especially like this interface of ours, right? It's of the same type, isn't it? We can compare their transmission speeds. If they are of different types, you just need to understand the main function, advantage, or focus of each type. As data continues to grow, our future performance requirements for storage systems will also become higher. And the quality modules will need time for continuous optimization and development, which applies to all of us. Regardless of the type of interface or hard drive, you need to develop and optimize them. At the very beginning, you can take a look at the hard drives from the last century. House ones, right? Server computers. By comparing them with what we have now, you can see that, first of all, the capacity is getting larger, and the size is getting smaller. This is a general trend, and in the future, it might become even smaller, like the hard drives. You see. Or some other components, like CPUs or memory, might continue to shrink. This is all possible with the development of technology. This is one of two types of backend interfaces. The main function of these two types of backend interfaces, and their application with the front-end interface, actually have different scopes. So, everyone should remember them separately, and not mix them up. These are the two types of our backend interfaces. If anyone wants to learn Huawei cognitive technology, or wants to obtain the Huawei certification question bank, please send me a private message. Or you can leave a comment below the video for technical exchange. That's it for today. Everyone, goodbye.